Hey guys, Mr. Moscato with you on this beautiful snow day. Yesterday we started talking about parallel lines and perpendicular lines. I think we got the parallel line concept pretty quickly yesterday, but I want to do a little bit of a review just to make sure that we're all on the same page. And then when we're done with that, we'll take a look at perpendicular lines in the next video. All right, so let me get started here. Let me just get set up, all right? All right, guys, so here we go. We have a problem here from the book. It says, write an equation in point-slope form for the line that passes through 4 comma negative 1 and is parallel to the graph at, or is parallel to the graph of y equals 1/4 x plus 7. So the first thing that we have to remember about parallel lines is that their slopes are the same, all right? So parallel lines have the same slope. Okay, so if the slope of my original line in this problem is 1/4, then any line that is parallel to that line has to also have a slope of 1/4. All right, that's really all we have to remember about parallel lines. Okay, and then once I have the slope and once I have a point on the new line, all right, then I can go ahead and create the equation for that line or figure out the equation for that new line, for that parallel line. Okay, so again, this is all we have to remember. Parallel lines have the same slope. All right, so let's figure out this problem. All right, so write an equation in point slope form for the line that passes through 4 comma negative 1 and is parallel to the graph of y equals 1/4 x plus 7. All right, so they want the equation in point slope form, which actually makes the problem really simple. All right, we're going to make it a little bit more difficult. Not really more difficult. We're just going to add to it, of course. All right, because we want to get a little bit more practice. All right, but we'll solve their problem first, and then we'll kind of take it to the next level. All right, so the first thing that we need to do is what is point slope form? All right, so remember that it's always a good idea anytime that you have a problem and they want an equation in some kind of form. All right, it's always a good idea to write out that general form of the equation. So the general form of the equation of a point slope form is, right, what do we have? Y equals, I'm sorry, y minus y1 equals the slope, right? We usually call m the slope, times x minus x1. Okay, good so far. All right, so that's the general form of point slope. All right, so what does all that mean? All right, well, it basically means that we have a slope m. Okay, this is the slope. All right. This is the y value of the point that we're given. This is the x value of the point that we're given. All right. This x is our input. Right. This y is our output. Okay. All right. So where do x1 and y1 come from? Right here. All right. This is the point that they're giving us. All right. So we can call this P1, right? Point 1. And point 1 is comprised of an x value and a y value, an x coordinate and a y coordinate. All right, so P1 will give us x1 comma y1, or P1 is in the form x1 comma y1. All right, so that's where those values are coming from. All right, so let's go ahead and answer this question then, right? So at this point, it's simple substitution. What do we have? All right, what values do we have? What values can we replace? All right, so we start with y, the left side over here. So y minus and then y1. All right, y1 is over here. It's a negative 1. All right, so y minus a negative 1 equals the slope. The slope is here, right? So remember that parallel lines have the same slope. So if my original equation has a slope of 1/4, then my new equation, my parallel equation, all right, is going to have a slope of 1/4 as well. Okay, 1/4 times what? Well, it's going to be worth 1/4 times the input x, all right, minus, and then whatever x1 is. Here's x1, here's x1 over here. All right, this is 4. All right, so we have y minus a negative 1 equals 1/4 x minus 4. All right, we can clean this up a little bit. All right, so we're going to say, because minus a negative over here is going to be plus a positive, so y plus 1 equals the slope 1/4 times x minus 4. All right, and that's it. This is our answer. All right, the slope-intercept form, all right, we do not distribute the slope through the parentheses. We leave it like that. All right, so there's our answer. Y plus 1 equals 1/4 x minus 4. All right, so let's do this. All right, so we have the two lines. Let's graph them. Let's prove that they are indeed parallel to each other. All right, so let me draw my xy coordinate. Right, so I'll put the xy over here. Okay, I'll put the y's over here. Hopefully we don't run into each other too much. All right, so this is my y axis. This is my x axis. All right, let's graph the original line. So y equals 1/4 x. All right, let's graph this. Y equals 1/4 x plus 7. Okay. All right. So the first thing that we know is that this equation, all right, is in what? Is in y-intercept form. Okay. So what we're going to do is we know that we have a point at positive 7, right? Y equals 7. So 1, 2, 3, 4, 5, 6, 7. All right. So we're going to have a point there. Okay, and then we're going to have a slope of 1/4, which means that we go right. Usually we draw uh, or we figure out slopes, up, all right, and to the right or down and to the right. Okay, so rise the positive or the negative value on top. Okay, we'll move our next point up or down, and then we are always going to run to the right. Okay, so at least we're consistent. You don't have to do it that way, right? We talked about a couple of different ways that people might think about slopes yesterday. Okay, but usually the way that I do it is I figure out, all right, if it's a positive slope, I'm going to move up. If it's a negative slope, I'm going to move down, but I'm always going to run to the right. Okay, so my next point here is going to be up 1 and over 4, all right, because we have a slope of 1/4. So up 1 over 4, 1, 2, 3, 4. All right, so this is another point here on the line. Okay, I can take my straight edge and connect the dots at this point. All right, and I'm going to have the equation of the line. All right, so this equation is of the line y equals 1/4 x, all right, plus 7. All right, good so far. All right, now we're going to graph, all right, now we're going to graph the other line that we created, okay, the parallel line that we created, this one down here. All right, so let's take a look at what that line will look like. All right, so there's a couple of different ways that we can do this. We can use the point that they gave us, all right, to figure out our first point, and then use that slope, all right, to move from there, okay, to find another point on the line. Remember that you only need 2 points, all right, to make a line. So let's just go ahead and use what they gave us, all right, for right now, and then we'll convert it to y-intercept form just for kicks, all right. So let's go ahead and do that, right. So our first point, all right, is over here at 4 comma negative 1, all right. So we're going to go to 4, 1, 2, 3, 4, and negative 1. So we're going to have a point there, okay? And then we're going to use the slope of 1/4, all right, to draw our next point. So our next point is going to be up 1 and over 4. So up 1 and over 4. 1, 2, 3, 4. Okay? So we're going to have another point here. Take my straight edge, connect the dots. Okay. And we're going to have something that looks like that. All right, so this is going to be, all right, the line that is parallel, all right, to our original line. All right, now this new graph, it looks like it has a y-intercept of -2. All right, let's do the math. All right, let's convert the point slope form of the line, all right, and see if we actually have an accurate representation of what we're trying to do. All right, so here we go, right? So we have this equation, y plus 1 equals 1/4 times x minus 4. Okay, we're going to solve for y. Remember that this is a literal equation, all right? We have two variables. We're going to solve for one of them. All right, we're going to solve for y, all right, in this case. All right, so what do we have? All right, so I'm going to get rid of the 1 over on the left-hand side by subtracting 1. All right, by subtracting 1. So we're going to say that y is equal to 1/4 x minus 4, right, or quantity minus 4, right, minus 1. All right, we solve for y, but we're not quite done yet. We want to get it into slope-intercept form. All right, so we do need to distribute the slope there through the parentheses only. Okay, so we're going to say that y is equal to 1/4 x. All right, 1/4 times a -4 is -1. All right, and then we have another -1, all right, from the left side of the equation. All right, so our final equation is y equals 1/4 x minus 2. Okay, in point slope form. I mean, in a y-intercept form. All right, and look at that. All right, we have a y-intercept of -2, which means that our graph was right on the money. Okay, these two lines are parallel to each other. Okay, this line, which is y equals 1/4 x minus 2, okay, is parallel to the line that is defined by y equals 1/4 x plus 7. The lines are parallel. They'll never touch. All right, they will move offwards to the right and up to towards infinity. All right, they will move downwards and to the left towards infinity. All right, but they will never get any closer together, and they will never intersect. All right, so that's basically what we have for parallel lines. All right, it's pretty straightforward. It's really not a big deal. All right, the most important thing that we have to remember about parallel lines is that parallel lines have the same slope. Okay, no matter what happens. All right, no matter what other points are around. All right, no matter what the y-intercepts are, parallel lines have to have the same slope. All right, so that's it for this video, all right, on parallel lines. The next video, we will deal with perpendicular lines. All right, so get yourselves a snack, maybe go build a snowman, all right, or at least help your parents shovel the driveway, and then come back and we'll talk about perpendicular lines. All right, this is Mr. Mascaro. We'll see you in a bit. Bye.